One of the qualities of Vedic mathematics is that it's fun. And this can be shown with lots of examples that involve patterns or very easy methods, and some of which appear to be quite magical and are full of interesting aspects. So here I'm going to look at the problem of finding the decimal equivalent of 1 over 19. And you might think that that's quite a boring thing to do. Certainly by long division, take lots and lots of steps, because this is going to turn out to be a recurring decimal. Now, the sutra involved here is by one more than the one before. And what this is to do with is when the denominator ends in 9, we can use that fact to work out this decimal very easily. So the digit before the 9 is a 1, and one more than this is 2. So 2 becomes the number we're going to use to work out the whole answer. The word by can mean multiply by 2, or it can mean divide by 2. And sure enough, we can work this out either working from the right or from the left, as I will show. We'll start with working from the right-hand end. Suppose we know that this decimal ends in a 1. So I'll write this here, and then I'm going to work towards the left. And the multiplier is 2. So 1 times 2 is 2, and 2 times 2 is 4. So we're just doubling here, then we get 8. Then we get 16, which is 6 with 1 to carry. At this point, we double the 6 and add 1 to give 13, which is 3 with 1 to carry. Double the 3 and add 1, we get 7. Double the 7 is 14. Double 4 and add 1 is 9. Double 9 is 18. Double 8 and add 1 is 17. Double 7 and add 1 is 15. Double 5 and add 1 is 11. Double 1 and add 1 is 3. Double 3 is 6. Double 6 is 12. Double 2 and add 1 is 5. And double 5 is 10. Now at this stage, if we were to double 0 and add 1, we'd arrive at 1, which is where we started with. And so the pattern will repeat at this stage. And this turns out to be the decimal equivalent of 1/19. So we put a dot above the first digit of the recurring pattern and also the last digit of the recurring pattern. And we have 18 digits. So now that's by multiplying, and now we're going to do it by dividing. This time we start from the left. So we get 1/19 is equal to, we can put down 0 point, which we know it starts with that. And the divisor is 2, and what we do is divide the numerator 1 by our divisor 2. And 1 divided by 2 is 0, remainder 1. And here we annex the remainder 1 to the left of 0, making 10. And then we carry on dividing. So 10 divided by 2 is 5. 5 divided by 2 is 2, remainder 1. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 2 is 1, remainder 1. 11 divided by 2 is 5, remainder 1. 15 divided by 2 is 7, remainder 1. And 17 divided by 2 is 8, remainder 1. 18 divided by 2 is 9. 9 divided by 2 is 4, remainder 1. 14 divided by 2 is 7. 7 divided by 2 is 3, remainder 1. Then we get 6 remainder 1. 16 divided by 2 is 8. 8 by 2 is 4. And then 4 by 2 is 2. 2 divided by 2 is 1. 1 divided by 2 is 0 remainder 1, which is back at the beginning. And so we can place our recurring points here and here. Now you will notice that I've placed these first 9 digits here and the second 9 digits underneath. Why? Well, if you look at these digits in pairs, they all add up to 9. 0 add 9 is 9. 5 add 4, 9. And we get 9s all the way. And if we were to include the remainder digits as well, here 10 add 9 is 19. 5 add 14 is 19. 2 add 12 add 7 is 19. We get 19s all the way along. Anyway, this property that we've got complements of 9s here in the second half means that once we've worked out the first half to here, we can just write down the remaining 9 digits by subtracting from 9. 0 from 9 is 9. 5 from 9, 4. 2 from 9, 7. 6 from 9, 3. 3 from 9, 6. 1 from 9, 8. 5 from 9, 4. 7 from 9, 2. 8 from 9, 1. And that halves the amount of work that we need to do. How do you know you're at the halfway point? There are 2 ways. One, you can look for the complement digits here. Or secondly, and intriguingly, you see this 18 here. This is the difference between the numerator and the denominator. So in this case, the denominator is 19 and the numerator is 1. And if you subtract, you get 18. So this decimal is full of intrigue and interesting patterns. And likewise, you will find the same with other fractions whose denominators end in 9. And if your fraction does not end in a 9, well, sometimes you can make it end in a 9. So for example, 1/7 is equal to 7/49 by equivalent fractions. And we can use the same method for working out 1/7. And there's a lot of interesting maths involved in this. Now, when it appears like this, it's just magic. When you understand the mathematics behind this, then it's both maths and magic.